So, not going to lie to you, kind of glad for two things today. One, I was glad that this April snowstorm was better than 5 years ago's April snowstorm. 5 years ago, we got 32 inches of snow in April.
No way.
In one day.
I don't remember that at all.
Yeah, it was bad. It was bad. We might not have gotten, I think we got, no, we didn't get that much. We only got like 18 or 19 inches. But other places, like just east of here, got 32. Like at my farm, we got 32 inches that day. Yeah, it was bad. So there's that. But I'm also glad because I was going to have to teach this lesson virtually today, and it just wouldn't have translated through the Google Meet, the stuff that needs to be done. So we're in person and all that fun stuff. So this week in Algebra 3 is quiz week. Okay, so Friday will be a quiz that will encompass all of your conic sections. This is the last. Hyperbolas are the last of the 4 conic sections. So we had parabolas, we had circles, we had ellipses, and now we're going to finish up with hyperbolas. Okay? Right? Oh yeah. So we'll follow the same format. Today we'll get the basics on how to graph it and do an extra graph. Then at the end, Wednesday we'll do some more graphing with them. Thursday we will go in reverse. This would be filling in the big quadrant on your supplemental note sheet. So should be the last of the 4 parts on that front page. And then after, so now that once we get all this stuff in there, then remember you have the back side of your supplemental note page to put on whatever you need to put on there from the rest of it. Okay? So let's dive into what a hyperbola is. So it's if you would slice, if you take a cone and you put another cone, and they at the points of the cones is where they touch. Okay? So a hyperbola is if you take a cross section of that. Okay? So you slice through both cones, you get what's called a hyperbola. Okay? So I gotta scroll down here. I think this is going to be in fact it is. Now hyperbola comes with, just like parabolas, it's a bola. Okay? So there's going to be 2 different formulas for your hyperbolas. The top formula, if x squared is positive, then it's a left and a right opening hyperbola. If y squared is positive, then it's an up or a down, up and down opening hyperbola. Not an or. And. So that can definitely go in your supplemental, or go on your supplemental note sheet. What a hyperbola is it is the set of all points where the difference of the distances is constant. So now an ellipse, remember last week, an ellipse was the sum of the distances to the foci was constant. Here in a hyperbola, the difference of the distances to the foci is constant. So if I were to take any point on my hyperbola, or on the hyperbola, so this minus this is the same as this minus this, is the same as that minus that. Those two subtract. Okay? All of those differences in lengths are constant. Okay? That's what a hyperbola is. It's a little more complicated. It's not a closed loop like an ellipse or a circle. It's an open curve like a parabola. It's a bola. Okay? So that's what a hyperbola is. Where can you see them in out in the real world? My favorite one is a lampshade. Okay? If you get a good lampshade and you got a darkened room, you'll see a parabola above on the wall and then a parabola below on the wall. Now, most times people's walls are kind of cluttered, or they have pictures hanging or something like that, so you don't have a blank wall that it's on. But if you get a good lampshade, you see the hyperbola. Yep. Sonic boom from a shock wave or from a supersonic jet is one. This is the planetarium in St. Louis. It's in the shape of a hyperbola. Radio signals, anytime you use a map before like radio positioning, kind of before GPS. Now your phone, like when you're using your map, it beams a signal up to a satellite. That's GPS, satellites and stuff like that. But before GPS, it was all like radio location, and that's all hyperbolas. And because it's all the circles and things are where you're figuring it out. In hourglass, all good stuff. All good things. All right. So let's start with the steps to graphing. There are more steps this time. That's why you're in the big section, why I had to do the big section down there. Yeah? Okay. So again, and I apologize because you'll probably be on 3 different pieces of paper, or at least 2. 1 you're graphing on pink, and 2 you're putting it on your supplemental note sheet. Okay. So here is the equation of a hyperbola. Now we have 2 things that we have to do in step number 1. Okay? In the past, so far, up to this point in time, what has been step number 1? Find the center. Okay, so find the center, find the vertex when we had parabolas. Okay, so that's the first part of step number 1. And we'll still have that part in here. Okay? But we also have to figure out, I think I might have actually put it as 2 steps, but whatever. We also have to figure out which direction the hyperbola is going to open. Is it going to open left and right, or is it going to open up and down? Okay? We'll need that for drawing it later. We'll need that for vertices later. We'll need that for foci later. Okay? So again, the kicker here is that you look for which squared term is positive. One of them in a hyperbola is going to be positive. One of them is going to be negative. In an ellipse, they're both positive. In a circle, they're both positive. Okay? Hyperbola is the only one that has a negative squared term. Okay? So if I scroll back here on back to here, if x is positive, it opens left and right. If y is positive, the squared term is positive, it opens up and down, which is helpful for us because x is the left and right variable, the horizontal variable, and y is the vertical variable. So in this particular one, which way does it open? Which squared term is positive? Y is the negative one. Oh. Why is the y negative? Because it's a subtraction sign. It's after the subtraction sign. So it's going to be the negative one. So x squared is actually positive. So this hyperbola is going to open left and right. Where is the center of this hyperbola? 3 comma negative 2. Okay, that is still the same as what we've had before. Okay, that's just like before. So my center for this one is at 3 comma negative 2. And again, I would put a C for that one, because it's not actually on the hyperbola. So 3 comma negative 2 would put my center right there. Now in steps 3 and 4, we are going to build a box around that center. Okay? That box, this box that we build, is a quote no-fly zone. Meaning there will be nothing that you draw inside of the box. Okay? All right? So just so you know, the hyperbola will not go inside of your box. So first off, we're going to look underneath the x squared term. For us, that number is 9. We're going to take the square root of that number, and that's where the sides of the box are going to go, left and right. So in this case, square root of 9 is 3. So we are going to put sides up on our box, 3 to the left, 1, 2, and 3. 3 to the right, 1, 2, and 3. Now right now I can only put the sides just there for right now, because I haven't figured out how far up and down my box goes yet. I'm about to do that here now in step number 4. Thought I had changed that and made those into their own individual steps. Okay? So then we look underneath the y squared term. What's the number underneath our y squared term? 16. So I take the square root of that one. Square root of 16 is 4. And that's how far up and down I go when I'm building the box. So I'm going to go up 4, 2, and 4. Down 4, 2, and 4. So there is the outline of my box. Now, you could dash in your box. So we have now built a box around our center. Now, what you're going to do is you're going to draw the diagonals of your box, because that is going to form the slant asymptotes of your hyperbola. Okay? Slant because they're on a diagonal, and they will always be on a diagonal. It's not like they're gonna be vertical and horizontal, because we're not gonna do twisted hyperbolas. Okay? So you have to put in ideally, you would use a ruler for this, or a straight edge or something like that, because this is going to give you the framework for your hyperbola. Now there's extra math that comes in on this one, and that is we have to also come up with the equations for the asymptotes. The wonderful thing about this, and this happens for all of your hyperbolas, the point that you're going to use is going to be the center, h comma k. Because if you'll notice, both of your asymptotes go through the center. So the point you'll use to find that is h comma k, the center. The slope of both of the asymptotes. Here's the other nice thing. Remember, you went up b, right? So you went up b, so this distance here is b, and then you ran, or you went over a in both cases. So the slope of your asymptotes will always be, one of them will be positive b over a, the other one will be negative b over a. Just from how the box was built. So in this particular case, our center, we said, was at the point 3 comma negative 2. Our slopes are going to be plus or minus. In this case, we said we rose 4, we ran 3, so plus or minus 4/3. We want them, or I shouldn't say we, I want the equations of the asymptotes in y equals mx plus b form. So first asymptote would be negative 2 equals positive 4/3 times 3 plus b. That's going to be negative 2 equals 4 plus b. So that's going to be negative 6 is b. So equation number 1 of our first asymptote would be, y equals, I used positive 4/3 x minus 6. Then I have to do it again, this time now with negative 4/3 as my slope. I have to do two equations. I've got two different lines, so I have to do this process twice. once with the positive slope, once with the negative slope. So then this is going to become -2 equals -4 plus b, which gives me +2 as my b. So the other asymptote equation would be -4/3 x plus 2. Questions on that? So step 1, we figured out which way it's going to open. Step 2, we figured out where the center was. Step 3, we built the box. Step 4, Alan, all your stuff's right there too. Step 3, we built the box. Step 4, we found the asymptote. Went diagonal of the box. Found the equations of those. Yep. Oops. Gotta bring my. Step 5 is the vertices step. There will be 2 vertices in a hyperbola. They will be the midpoints of the sides of the box that you just made, depending upon which way your hyperbola opens. So since this is x squared minus y squared, and we determined in step 1 that this is a left and a right opening hyperbola, the vertices are going to be right there and right there, because it's a left and a right opening hyperbola. So those 2 vertices would be 0, -2, and 1, 2, 3, 4, 5, 6, -2. Now we get to draw it in. In step number 6, we draw in our hyperbola. The nice part is there's no guesswork for it anymore. We know it goes through the vertices. We know it's got the asymptotes here. So we just, oops, I missed. So we just hit and move it along. It just ends right along the asymptotes. Step 1, which way does it open? Step 2, center. Step 3, draw the box. Step 4, diagonals of the box. Step 5, vertices. 6, draw. What's wrong, Blondie? Oh, can't see, that's right. I forgot. Contact, wrong sides. Okay. One more step to go. Yep, one more step. Okay? Because now we've got to have our foci. Okay? Just like, oops, that one got brought in there too. Sorry about that. Just like with an ellipse, there is a special formula for the foci of a hyperbola. The nice part is that this equation for the foci of the hyperbola should be recognized by you. What is it? A squared plus b squared equals c squared. It was in geometry. Pythagorean theorem. Pythagorean theorem. Okay? Okay? So you just have to use the Pythagorean theorem for the foci. Okay? C is going to be still the distance from the center to each focus. This is a key little sentence right here. The focus, the two foci of your hyperbola are inside the curves. Okay? So the foci are inside the curves, which goes to show with all of the other conics. Okay? In a parabola, your foci was inside the curve. Okay? In a circle and an ellipse, your foci were inside the closed loop. In a hyperbola, inside the curve. Okay? So a squared is the number underneath the x term, b squared is the number underneath the y term. We already saw those when we did step number 3 and we built our box. So in this case, a squared plus b squared is 25, and the square root of 25 is 5. So the distance from the center to the foci, because it's a left and a right opening, it gets added and subtracted to the x part of the center. So the foci are located at 3 plus or minus 5, comma negative 2. Well, 3 plus 5 is 8. 3 minus 5 is negative 2. On the graph, again, the distance to, I don't know, why are we jumping around here, smartboard? The distance to the foci is 1, 2, 3, 4, 5. So my first focus would be there, which is the point 8, comma negative 2. The other one, 1, 2, 3, 4, 5. My other foci is right there, which is the point negative 2, comma negative 2. Okay? Alright? So, once again, your supplemental note sheet should have hopefully a little bit more information than what I have here on these. But so you should have the two equations for sure, and then the 7 steps to drawing or to graphing one or graphing a hyperbola. So number 1, again, the 7 steps are 1. Which way does it open? What are the directions of the two curves? Left and right or up and down? Okay. X squared is positive, left and right. Y squared is positive, up and down. Step number 2, find the center. H, comma, K. Step number 3, build the box. Step number 4, diagonals. Okay. Draw the diagonals of your box and then come up with the 2 equations for the asymptotes. Couldn't think of the A word there for a second. Step 5, find the vertices. Step 6, now we can finally draw it in. And step 7, find the foci. So there is a lot of information that I can ask you from a hyperbola. First thing I can ask you is I can ask you what the center is. Second thing I'm going to ask you is I'm going to ask you what are the equations of the 2 asymptotes. Next thing I'm going to ask you, what are the 2 vertices? And lastly, I'm going to ask you, what are the two foci? Okay. So there are 7 key parts that I'm going to ask you, and if you'll notice on this week's homework sheet, okay, I ask you for all 7 parts of those on each one. Center, actually, I even ask you direction of opening too. Center, direction of opening, asymptotes, 2 vertices, 2 foci. Okay? Sounds like a plan? Good times. You can start the front side of your homework this week. You might need to have a supplemental sheet to go along with it because there's some work that gets involved, especially when you're writing